So hi all, in this video we'll be talking about classes and objects. So these will be a series of videos where we'll be going over each module present here in low level design mastery. So if you want to follow along with me, you can just head over to low level design mastery and then come to here. So this is the first module that we'll be talking about, that is oops refresher. So we'll be going over each module by module. Second one is the class relationships, design principles, patterns, and so on. So the reason why I am going with oops refresher is because even though our main goal is to learn LLD, it is very useful if we just refresh our oops basics once again. So if you are familiar with oops, you can just skip this video or series of videos that come under oops refresher. But if you want a quick refresher, you can follow this video. Okay, so let's talk about classes first. So a class is a blueprint or a template for creating objects. So we'll see what objects are, but so what does class have? It says class have attribute and methods, right? So attributes are also called as data or the variables that classes have, and methods have the functions that operate on this data defined, right? So what is an object? So object is an instance or a specific realization of a class, right? So it's a concrete example that is created from a blueprint. So we'll use this blueprint, that is the class that we defined, and objects are nothing but an instance of a blueprint. So here is a simple real world analogy, think of it like as a cookie cutter. So let's say we search for cookie cutter, and then I guess this image makes more sense. If you see whatever the steel thing that the person is holding, so that is the class, right? So what are you doing that using the blueprint? So you are creating instances of a class. So all these two stars that you see here, they are instances of this class, right? So and each of them have their own properties. So that is what instances are in a simple real world analogy. That's all. Okay, so class is a cookie cutter, right? As I was saying, and the objects are the cookies. So all the cookies made from the same cutter have a same shape, but each cookie is a separate object. We already talked that, right? So each cookie is a separate object, but they all have same shape and same dimensions because they are all coming from a single blueprint. So, so this is the basic class structure. So we defined a class here, and then for now we have just declared it as empty class, so we just wrote pass. So how do you create instance of a class? So you'll say something like my dog is equal to the dog class that you defined in the line number 1. So when you print type of dog, you see the class coming. So same or similar thing goes for Java too. So you define a class here, and then your main, so what are you doing? You are creating dog, my dog is equal to new dog, right? So new dog means you are creating a new instance of a class dog, and then you are naming it as my dog. So what's the type of my dog? It's the dog class. So when you print this thing, you'll get the class name. So now let's talk about the constructor. So a constructor is a special method called when you create an instance of a class. So as soon as you create instance of a class, this is some special method that gets invoked automatically. So you don't need to call it separately. This gets called automatically, right? If you see here in Python, so we declared a class dog, and then we wrote this special method, right, in it. So this is the constructor method which is called when creating a new dog instance. So whenever you create a new dog instance, this gets called immediately. So how are you creating that? We created dog1 is equal to dog, and then we passed name and breed here. So similarly we created dog2, and then we passed name and breed here too. So when you print dog1 dot name, you'll get buddy. So how do you get? So as soon as you created the instance of this class dog, so this init gets called, and whatever name and breed that you are passing here, that will be stored as variables for that instance of a class. So this is all about constructor. So now let's understand self and this. So in Python, self refers to the current instance of a class. So whenever you want to refer to the current instance of a class, you use self in Python. So it's the first parameter of the instance method. Now in Java, this refers to the current instance of a class. So in Python you use self, whereas in Java you use this, right? It is used to distinguish between instance variables from a parameters. So we'll see this with an example. So these are the key points. So self are this allow methods to access and modify instance attributes, right? So you use self to refer to the current instance, and how do you modify them? You use self. So in Python, self is always the first parameter, and in Java this is used explicitly. So we'll see an example. So we'll see an Python example first. So we declared a class person, and in the constructor method we have two variables defined here, so self dot name and self dot age. So you are taking two arguments, name and age. So whatever the name and age that you are passing in, they are getting assigned to this instance attributes. And then there is a method called as introduce, and if you see, it is taking an argument called self. So self refers to the instance of this class, right? So if you say hi, I am self dot name, that means how are you accessing this name? How are you accessing the name variable, that is the instance attribute? You are doing it via self dot names. So this is what this key point says. So self for these allows methods to access and modify instance attributes. So how are you accessing these instance attributes? You are saying self dot name, and I am self dot age years old, right? So these self is used to access the instance of a class. So using self you access or modify the instance variables. So that's all. If you see person, we are creating a new instance of a class person, and then when you call person dot introduce, this line gets called. So let's see a Java example now. So here we have a class person. Same, we have two instance attributes here, and then this is our constructor which gets called as soon as you create this class. And then what is introduced doing? So it's saying hi, I am this dot name, this dot age, right? So how are you accessing the instance attributes? You are doing it via this. So if you see in Java, this is used implicitly or explicitly to refer the current object, right? Whereas in Python, if you see in Python, you self is always the first parameter of the instance method, right? If you see, it's the first parameter of the instance methods. If you go to Python, you see that so self is always a first parameter, whereas in Java there is no need like that. You can call it implicitly, or you can also call it explicitly. So this is how you're doing here. So in the main class you create a new person instance, right? And then you are just printing that person, so you will get the same as output. So this is all about self and this. So self is used in Python and this in Java. So only thing is both self and this are used to refer to the current instance of a class. Now moving on to instance attributes. So we already saw instance attributes, but let's have a look again. So instance attributes are the variables that belong to a specific instance. So if you remember in our previous example, we said that each cookie cutter is used to create cookies, right? So individual cookies are instances, right? So each of these individual cookies have their own properties, right? So properties in the shape, the size, etc. They are independent to each cookie. So instance attributes are variables that belong to a specific instance, right? So whenever you create an instance, so each instance gets its own copy of variables. So that is what we are doing here. So let's see. So whenever you do create an instance of a class, let's say account one, now account one gets its own copy of account number and balance. Similarly, account two gets its own copy of account number and balance. And whenever you print, right, account one dot get balance, you'll get 1000. Whenever you print account two dot get balance, you get 500. So each instance that you create here is getting its own copy of values. So this is all about instance attributes. The same thing if you go to Python 2, so that will be the same instance attributes. So you created a class, and then each class has each instance has its own set of or copy of attributes, and then whenever you print account one dot balance, you'll get the 1000 as its output. So now instance methods. So we saw that these are instance attributes, and whatever all the methods that you define, these are called instance methods. So instance methods are the functions defined inside a class that operate on instance data. So these are all the instance methods, right? So they are defined under a class. So instance methods are defined under a class, and we use them to operate on the instance data. So this is the instance data, and we use these methods defined to operate on the instance data. So if you see what is deposit doing, it is checking if the incoming amount, that is whatever we are passing here, is it greater than 0. If it is if it is greater than 0, then we are adding that amount to the balance, and then we are returning this line. So how are you, so what variables are these methods acting on? They are acting on the instance attributes, right? So same thing goes for withdraw. So it will check for the amount. If the amount is something which is greater than 0 and less than the balance that you have in the current bank account, then what we'll do, we'll just minus from the balance. You'll return this, withdraw so and so amount, and this is your no balance. Same thing for get balance. So now we are creating a new instance of the class bank account, and then you are depositing 500, withdrawing 200, and finally you want to print the balance. So it says depositor 500, new balance is 1500, withdraw, and then so on and so forth. So main thing is instance, like how we have instance attributes earlier, which are, the variables that belong to the specific instance. Instance methods are also same, but these are methods and they are attributes. So we use these methods, and these operate on the instance data that we defined. So this is all about instance methods. So in Java, if you see, it will be the exact same. So this is our constructor class, and deposit, withdraw, all these things are the instance methods. So if you want to, understand better, just open your IDE of your choice, copy this code samples here, run them and see, try to play with them, tweak them, and understand how this works, right? So now let's proceed with the complete example from whatever we have learned so far. So this is a user class. So we already know that init is a constructor class which gets called as soon as you create an instance of a class user, right? So you are taking username, email, and age as parameters here, and then you are initializing them here. So you are storing them as instance attributes. And all these things are instance methods, right? Get info, deactivate, activate, update email. So all these things are instance methods. So here what you're doing here, so you're creating user one, which is instance of a class user, and then you're passing this name, email, and age, right? So whenever you call user one dot get info, so you are essentially calling this get info method, and then this is the print that you will be getting onto the output. So if you see, this is the print that you are getting, right? So this is a blueprint, right? So you have a user class, and then username, email, age, active, all these things are the instance attributes, and then all these things are the instance methods. So we'll see what are this plus, minus, and all these things later, but for now just understand that this is how you represent a class. You have a class, that is the blueprint, and all these instances are created from this single blueprint. So why do we have classes in general? So what happens is, let's say without a class, you want to store user data. So how do you store? You create individual variables like username, age, email, and all these things. So all these things will be cluttered when you just create them as separately. But what if you can group them? So class gives you that concept of grouping. So you can group data that belongs together. So with class, what you get, a class, a user becomes a clear single unit, right? So all the data that is belonging to the user, you can group them together. I mean, in general, that is what classes do, right? Outside. So in school, you have classes. So what are they doing? They're just grouping a group of students into a single class, right? So with a class, you get that clear grouping. So you can understand the data, whatever data that lives there, how to access those data. So classes are not just a syntax, but they are used for organization, right? To organize the data which is related and the behavior that is related at a single place. So this is all about classes. So key takeaways are, so class is a blueprint we saw that so object or instance is a specific example from a class, and constructor is a method that get calls as soon as whenever you create an instance of a class, and self for this used to refer the current instance. What are instance attributes? We saw these are the variables that belong to the instance methods are the functions that operate on this instance data that you defined earlier, and each instance is an independent instance, and then use classes to organize related data and behavior together. This is what we just saw. So this is all about classes and objects. So I encourage you to go over this article once again, pick the language of your choice, copy this example, paste it in your IDE, run it, see how it works, try to add a new method, try to add a new instance attribute, right? So see how this works so that you'll get a very good glance of this concept. So thank you all. In the next video, we'll be going to look at enums.